Hello students, in this video we'll discuss Cartesian products and counting the number of elements in our Cartesian products of two sets. So if we're given two sets, A and B, we can form their Cartesian product. And the Cartesian product of two sets A and B is denoted A cross B. And what A cross B is another set, and it's the set of all pairs A, B in an ordered form, such that A is in A and B is in B. We're very used to seeing Cartesian products from just ordinary geometry, so for an example, we can look at just the Cartesian product of the set of real numbers with itself. So for example, if we look at the real numbers cross the real numbers, we're used to writing this set as just R2, and this is just the set of all points x and y, such that x and y are real numbers. And we can geometrically visualize this set as the Cartesian plane. Here's the x-axis, here's the y-axis, and a generic point is something in the x direction, something in the y direction. So that's the point x, comma, y. I can do this Cartesian product construction for any sets though. So for example, as another example, I can look at the Cartesian product of the set 1, 2 with the set 3, 4. And let's list the elements of this set. Well, I could have a 1 and a 3. I could have a 1 and a 4. I could have a 2 and a 3. Or I could have a 2 and a 4. And so we note from this that this Cartesian product over here, so note this Cartesian product has 4 elements. So it looks like the Cartesian product, so I have 2 elements over here. The cardinality is 2. I have 2 elements over here. So the cardinality is 2. And it looks like the cardinality of the product is 4. So it leads us to conjecture that if I have a Cartesian product of two sets, the cardinality of the Cartesian product, for finite sets anyway, is just the actual product of their cardinalities. And in fact, that's true. So let's state that. So the number of elements in A cross B is the number of elements in A times the number of elements in B. And we can prove this by induction, or we can prove this just by visualization. So what we can do is we can think of this axis over here is my A-axis, and this axis over here is my B-axis. And what I can do is I can write down the points, maybe A1, A2, AN. So there's n points over here in A. So in other words, the cardinality of the set A will just be n, since I've written them out. And then over here I'll do a B1, B2, all the way up to maybe B sub m, right? And so the cardinality of B is equal to m. And what I can do now is the Cartesian product is all of these points over here. And so of course this goes on. So there's a little, this pattern persists, this pattern persists, that pattern persists, that pattern persists, that pattern persists. And so what we have here is we have dots in a rectangle. So the height of this rectangle over here is m, and then the base of this rectangle is n. So indeed from this geometric figure we see that the cardinality of A cross B, all these Cartesian products, is equal to n times m. Now, note that if one of A and B are infinite, so note if either A or B are infinite, and we're not going to worry about countable, uncountable, we'll just say infinite for now, because there's lots of work to be done to show that the cardinality of the Cartesian product is related to the cardinality of the individual terms in the product. So we'll sort of sweep that issue under the rug and just say that if either A or B are infinite, then the Cartesian product A cross B is also infinite. And we should say if B is not empty, right? So B should not be empty for this to be true. There's lots of strange things that happens when you have the empty set, and so we'll sort of think about that in sort of special cases. But the main idea is that if we have two sets, I can form their Cartesian product just as simply all ordered pairs of points from the first set with points from the second set. Thank you very much.